Sure, I have this recording, guys. That way I don't miss out on something. So we're going to wrap up geometric series. So this multiplying over and over again. I believe we got to the middle, which was slide 20. Correct me if I'm wrong on the chat. Well, now you're making me hungry, Jordan. Now I want food. So the idea of this geometric sum, I know it's intimidating, but just remember, all it is, this weird, complicated thing, is just this formula. What we start off with, what the thing that we're multiplying by every single time. So in this case, it's 2/3 that we're multiplying by every single time. And then n, how many terms there are. So if this is a 49, there's 50 terms because we start at 0. And then 1 minus r. So if it's 2/3, 1 take away 2/3, we're left with 1/3. All right, and then we would just plug this in and it would give us a sum. So the interesting part about this is it ends up, in the case of this one, it ends up kind of creating a 1. This exponent is so big for this fraction that that fraction becomes really, really tiny, and it's basically 0. So what this means is when we're multiplying by a fraction, we'll see that eventually it stops. It basically never gets higher than this. So I think that's what we're going to learn about today, because that's one of the topics here. We did this one already, how to do it over and over and over again. One thing that I totally forgot I could have done was I could have realized that all I had to do was -4 divided by 2, new over old. That's how you find your common ratio, new over old. I'm always multiplying by -2. So what I could have done to make this easier yesterday, I know I skipped a lot of steps, but what I could have done was this. Gone on Google Calculator. I don't expect you guys to know like a lot of these little tricks, but I realized it later. I could have done this. I could have done 2 parentheses -2 and then just tried out numbers for the exponent. Because what I'm doing here is instead of doing 2 times -2 times -2 over and over and over again, I can just try a random number until I get to this number right here. I could have done something like, let's say I was like, oh, I'm going to try 9. Oh, that's really close. Let me try one more time. Cool, so the number's 10. So let me see if that's true. 2 times -2, close the parentheses, to the power of 10. So I find that that's true. So that ends up being true. So instead of doing like, oh, that's not true, let me do it again, I can just use this exponent form to do it. And that's where this comes from. This idea right here comes from, is we would have just done this. 2 -2 to the power of k. So in this case, my k would be 10. So there's 11 terms. And I could always use the formula for all of those to figure it out after that. So just remember, when we're doing a geometric series, we're adding them all up. Our formula is first term times 1 minus our common ratio, the thing that we're always multiplying it by over and over again, and n, number of terms. So I recommend you guys have this written down somewhere. If you guys haven't noticed yet, after algebra, math becomes its own language. Like, you kind of have to start learning all of these words to understand it. And that's how you technically should have been taught math from the beginning, is language. Like, for example, 10 plus 5. This seems easy, but if you think about it, it's 1 in the tens place, 1 in the fives place. So if you combine them together, you have 1 in the tens place, 1 in the fives place. So just be aware of that. Make sure you're taking notes on like the special words. That's why I'll tell you like, hey, print this out, print that out. I'll start seeing what other resources I can do, and that might be something I start doing in the study hall. So now we're going to talk about infinite series, series that go on forever. So remember that 3 that I was talking about earlier? The reason why I mentioned that, even though we had covered it before, is even if I add more terms, what happens is, since I'm multiplying by a fraction, at a certain point in time, that fraction becomes teeny tiny. I don't even know what would be next. Oh, 81. I think so. Let's pretend I'm right, even if I'm wrong. But I'm pretty sure that's the last one I remember. Next one, 1 over 2, 4, 3. Yeah. Yes. So what I'm doing here is I keep multiplying by 1/3, right? Assuming that my first term was 1. Well, what's happening is this number is really, really small. Basically, what happens when 1 over a number gets so big, it's basically 0. Think about it logically. Like, if you keep cutting something in half over and 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 over, eventually there's like nothing left. That's what we're going to be talking about here. This idea that if you keep cutting something over and over again, it gets to the point where there's nothing left. So let's see what we got here. So this is a formula for infinite, meaning that we're going to go on forever. They're going to prove to us why we're able to find this formula, that you can add up something that goes on forever, but it's still only a small number. Now, the idea here is if we're adding on forever, that's what this little infinity sign means. We're going to keep adding this stuff forever. It's only the first term, so whatever the first term is, divided by first term, the first number divided by 1 minus our common ratio, the thing that we keep multiplying by. So minus common ratio. And this only works if we're multiplying by a fraction. And it could be a negative fraction. That's why they have the absolute value. They're just saying like, hey, it's a fraction. It's between 0 and 1. Some type of fraction or decimal. So, and that's from, like I said, if you keep cutting something in half over and over and over and over again, and you add all of this together, you get a fixed number. All right, so let's take a look here. So for example, this one, we start off with 2, and then we add half a 2. All right, so if we start off with like a big 2, and then we're going to add half of it, so we're going to add 1, and then we're going to add a half, and then we add a quarter of 1, and then we're going to add an eighth of 1. Eventually, these things that we're adding up together get so teeny tiny that it's like you might as well just stop. Like, there's no point. So, if we wanted to add these going on forever, we would be like, hey, just take 2 divided by 1, take away 1/2. We keep multiplying by 1/2. And what you get is 2 divided by 1/2, which is the same thing as saying 2 times 2 over 1. we're going to flip the fraction over, which is just 4. So that's how we do this. That's how we figure out this. So if we had 2 pieces of something and I tell you every day I'm going to give you a half of it, eventually I'm going to stop giving you money. So let's just say that I tell Nelson, like, hey, Nelson, today I'm going to give you $2, right? But like, let's say Nelson buys me a $10 pizza, and I'm like, all right, how about Nelson? What I do is I pay you $2, and then every day I'm going to give you half of what I gave you the day before. And Nelson's like, oh, and then I'll tell you forever. And Nelson's like, that sounds like a deal. Nelson's like, I get to, yeah, but you spent $10, Nelson, for that pizza. So Nelson's like, well, if he keeps giving me money forever, that sounds like a deal because when we did the penny example, the penny became a lot more over time. So this has to be a good deal too. Well, what Nelson doesn't know is eventually I'm going to give him money that's smaller than a penny, which means at a certain point, he's only going to get $4 for that $10 pizza that he bought me. Small price to pay for salvation. Wow. So Nelson ends up losing $6. That's just a general example, but that's the idea is if you keep adding something that gets smaller and smaller over time, eventually you get nothing. So I can't give Nelson anything less than a penny. That's a real world application of it. So let's take a look at this. So this one, it looks like we keep multiplying it by a half. Or what are we multiplying this by? Okay, so remember it's always new over old. So the new term divided by the old one. Always new over old. That's how we find common ratio. All right. So in this case, where our common ratio is 2 over 5. I just reduced it. All right. So if we're doing that, we're going to say that this one is going to be our first term is 10, and we're going to divide it by 1 minus 2 over 5. And this next one is 1 over 5. And it looks like we're going to multiply it by 3. Yeah, this one we keep multiplying by 3. See how this turns into 1, 2, 3. So the formula for this one wouldn't work. So this one keeps getting bigger and bigger and bigger. So let's say I talk to Nelson. It's like, all right, Nelson, I give you 2 options. I can give you $10 today, or I can give you 1/5. What's 1/5 of a dollar? Or I can give you 20 cents and then I'll triple it every day. Which one would you want to get? So a lot of people go like, oh, $10. I want the $10 right away. But then because it keeps getting 2/5 over and over again, it keeps getting smaller and smaller. This one runs out of money. And this one keeps going on forever. It starts off tiny, but it gets really big. The other one starts off big, but then gets to the point where it's 0. So these are 2 different parts to pay. All right. So series A has a value of, we would have to figure this out. So series A, we said this was 10, 1 minus 2 over 5. So that means if we had a pizza, we took away slice, that means we have 3 over 5 left over, which would end up being 10 times 5 over 3. So we have 50 over 3 is our answer. I don't know if Edmentum's going to accept this, but I'm going to try. So the sum of the series, the value of R, the value of the common ratio. 2 over 5. What is the thing? So we said that one was 50 divided by 3. So that's how we figured this out. First, we had to figure out which one was. This is what's known as a. Oops. This is what they call divergent or convergent. Convergent meaning it converges. It gets tiny to the point where it stops. The other one is known as a divergent, meaning it keeps getting bigger and bigger and bigger and bigger and bigger and bigger forever. All right. So moving on. Solving contextual problems using geometric series. So now they're going to give us real life problems. They're not going to give us these problems that I made up with Nelson buying pizza. All right. So when we've seen some of geometric series before in the past with R. So when is it that we keep cutting something in half forever? But how can we use this knowledge? So let's consider, so Audrey is saving money for a new laptop. Okay, so she has $50. Then each week she puts aside 5% more than she did the previous week. So, in other words, she keeps putting more money, 5% more than what she did the previous week. How much money will Audrey have saved after 6 weeks? All right, so let's see what's happening here. So, what we're doing here, this one is we are going to keep multiplying over and over. So, what's happening is she is technically putting more money. She starts off with a little bit and then more money and more money and more money. So let's see what we have here. So after a while, it gets to the point where 5% more is nothing. Like she's not adding any more money. So let's see what we have here. So here's what's happening. First, she puts $50. Then she puts $50 plus 5%. Then she puts another $50 plus 5%. Then another $50 plus 5%. Oh, going on over and over for 5 times. So if we ignore the $50, how much more is she adding every single time? I feel this is a weird example, but they do it. So after a while, her savings becomes $341 after 6 weeks. So they're using this formula, 1 minus the R. So after a while, she's not putting any more money after that $341 after those 5 weeks. All right, so now, here's going to be an option. Who wants to be example? I'm going to start picking on people. I've been picking on Nelson. Does anyone want to volunteer their name? Me. All right, Carter. Carter. So your parents are offering you 2 options for your allowance to do your chores. So your parents are giving you money. Given 2 different payment options for 2 weeks. So, Carter, do you want to get $20 every week? Or do you want to start off with a penny and that penny doubles every week after that? Which one do you think you want to get, Carter? Start off $20 a week flat, or you just get a penny the first week, 2 pennies the next week? Let's find out. So, honestly, I would go for the doubling. It kind of sucks at first, but after a while, that thing keeps doubling over and over. Yeah, and Carter's picking the same thing. Like, let's get option 2 for those pennies. Um, so he would take option 2. After a certain point in time, he will make more than $20 a week. And I don't even think it takes that long, to be honest, because if we look at it, all right, so let's do it this way. So if we start off at a penny, our A is a penny. That's how we start off. And then what we're going to do is we're going to do 1 minus R, which was 2. We keep doubling it. And then we're going to multiply that by however many weeks. So let's say, I don't know, let's do 10 weeks. And then we're going to divide that by 1 minus R. So what ends up happening, am I doing this right? I think I'm using the wrong formula. Oh, and of course I closed that tab where I needed that formula. Well, you guys will get the idea. Give me a second. Let me go back to this. So the sample answer for this would be like if we do 14 weeks. So they're using 14 weeks. So let's use their example instead of mine. So that means our N is 15. So they're doing N for 15. Oh, it was doing it right. So what ends up happening here is we're going to do this 2 to the 15, and in week 14, Carter would be making like $300 a week, and it keeps doubling it from there. Well, actually, this is the total. After 14 weeks, he gets that. But after 15 weeks, he's only going to get 300. So in the short term, yeah, it sucks. But in the long term, it keeps doubling and doubling and doubling. And any week after this, Carter's making way more money. Was it only for 15 weeks? Oh, 15 weeks. So there was a cap on it. It capped at 15 weeks. So slightly better, but if Carter wanted to do something with the money right away, he would do that option. But this one, he ends up making more money. This is the sum formula. They already added up all the money together. All right, so structured savings plan. So this is how we calculate savings. So if you guys ever had an account, a savings account, the interest rates are really tiny for savings account. And the reason for that is if you leave your money in the account for too long, it starts getting really, really big. Now, one of the issues with that too, well, I don't want to get into it, but let's pretend that your savings stays the same. So the thing with interest rates is they pay you every month, although we measure it every year. So for example, they say you make, I don't know, I'm going to say if you look at Chase, for example, they only pay 0.01%. So not a whole lot. That means for every dollar, they give you 100th of a cent. Nothing, because this is in the hundredth place. So that means you need at least $100 for them to give you a penny. So it's tiny. And that's in a year. Now, the problem with this is Chase doesn't pay you the penny every year. They're like, hey, we're going to take this penny and divide it by 12, which means they're not giving you anything. So you want something with, if you have money in the bank for savings, you want to make sure you have a lot. Otherwise, you don't make any money. Yeah, it does. So you need to have a lot of money to do it. There was one time one of my friends had like $300 in their savings account, and I think they had it in there for a year, and then like a year later, they still had $300, and that was because their bank account didn't pay. Their interest was so small that they still didn't make any money. So I'm sure they're going to give us examples with better interest rates. So let's take a look here. So this one, they're paying 3% and they have a lot of money. So 3% is pretty good. Pretty good interest rate. And they have a good amount of savings too. So you need to save a lot of money for the bank to start paying you money back. So in this case, we're going to plug it into our little formula here. the formula they gave us to calculate how much money we make after a certain amount of time. So they said 8 years. So what we have to do here is we have to take our percentage, divide it by 12, because there's 12 months in a year, and we're going to take our 8 years and multiply it by 12, because again, how many times have they been paying you? Well, they've been paying you 12 times every year. So for that example I gave you guys earlier about my friend, $300, 1 plus 0.0001 over 12. So this tells you that 0.01% is basically nothing. They're just putting a number there to tell you, like, hey, we give you money, but they're not giving you that much money. All right. And then you're going to multiply by the number of years. So they had it in for 1. And after that, it equaled $300 still, because it was so tiny. But if you have a higher amount of savings and a higher interest rate, you make a lot of money. In this case, you made like $7,000 in those 8 years, not doing anything, just letting your money sit there for 8 years. Hey, I didn't even notice this was me. Hey guys, I need to find out where I can get this money from. I didn't know. I think I've done this with other students before, and I never read the name. All right. So next, we'll work out a similar situation. In this case, we're going to do a geometric series. So geometric series, again, we're going to multiply it over and over and over again and see what we get over a set amount of time. So if it's a set amount of time, this is what's known as finite. It's not infinite. It's finite. I always found this weird, that this is infinite and this isn't finite. This is finite. This is why people don't like English. All right. So moving on, besides my English rant. All right. So Esther would have saved. So we need to figure out how much money she's saving for college. So in this activity, we're doing geometric, blah, blah, blah. Esther is comparing ways to invest money. So she deposits $50 in the bank, no interest. She would have to say, how much money would she have to save for 12 months? $50. Oh, every month she's depositing $50. So her bank doesn't pay her interest. So we're just going to do 50 times 12, right? So in other words, and it's every month, right? So it's not 50 times 12, it's 50 to the 12th power, because, oh wait, we're adding this over and over. Blah, sum. So it's not 600, which we'll see right now. Oh, it is 600. They're the 50 times 12. I'm thinking about geometric series. I'm sorry, guys. So first month, 50 plus another 50 plus another 50. So instead of doing 50 plus 50 plus 50, we already have a method for that. It's called multiplication. Multiplication is just addition over and over again. So the next one we're going to do is, all right, so Esther, she's getting this much in interest. They get paid every month. So her first deposit is 50. At the end of the year or 12 months, use the interest rate formula to figure this out. So our interest rate formula is always P1 plus R divided by 12. It's technically supposed to be T. T is the number of times that we are getting paid. So we get paid 12 times a year. And then we're going to have N times T, how many times we get paid a year. So when I do this formula, I'm going to get my principal. My principal is $50. times 1 plus, this is over 8 years, right? You have to figure out the investment, the interest rate, which means $50 would be worth it at the end of the year. We're doing 1 year. So if we're doing 1 year, we don't need an n. So this is going to be 0.036, because we have to do it in a decimal, over 12 to the 12th power. So doing this, let me grab Google Calculator. So we're doing Google Calculator. 50 parentheses 1 plus, and I have to do another parentheses for a fraction, divided by 12. And now we need a power after this parentheses. So I have to kind of tell the calculators are stupid, guys. A lot of people put a lot of faith in calculators, but they're dumb. I have to put parentheses to tell the calculator, like, look, this is a fraction. I know you're too dumb to know that it's a fraction, so I have to put a percent there. And we're putting a plus sign here. And now I can finally put my exponent, which is going to be 12. So after that, she only made like $1. So after that, all she made was like $1.83. Because she has very little money, and even though it's an okay interest rate, we made $1.83. Oh, shoot. Percentage per month. Oh, they're getting all fancy. They want to know the percentage per month. So 0.036 divided by 12. So it's that much of, oh, my bad. They want the percentage. They're getting really picky on this. So 0.3. So how much does she get paid a month? 0.3%. How much is it worth after a year? Well, that's that big old thing that we calculated. So they did it a little nicer than I did it. They're like, hey, just figure out how much she makes a month. And I was like, okay, so this is plus 0.0000. Oh, I forgot the 6. So when you make it into a decimal, it becomes 0.0036. So that's how much she gets paid a month, and it's going to be over 12 months. So their formula was a lot easier than mine, but I'll show you that this is the same thing right now. 50 parentheses 1.36 0036. Oh my gosh. 6. Hit this little exponent to the 12th power. And what did I do wrong? Oh, I was supposed to divide. I divided it by 12. I'm sorry, guys. I am so sorry. I'm like out of it today. You guys are probably asleep by now. I'm sorry. 003 C's up. Oh, say hi if you're not asleep right now because of how boring this is. Okay, cool. Some of you guys aren't asleep yet. I'm sorry. I know this is boring, but this is a good way of kind of seeing what your money does. I've talked to other people about how I save money and they get really bored. So let me do that. And apparently I forgot that this is supposed to be a 3. No, it erased all of it. 51.83. I don't know how to round and I just ignore numbers apparently. Okay, I give up. 83. Why did I do that wrong? 63. Now it's just messing with me. Oh, they're mean. We're only doing it for 11 months. So, yes, she put money in there the first month, but we're only getting interest for 11 months. So that's Edmentum being Edmentum. But to be fair, they do have a point. It's like you don't get interest for 12 months because the first month you didn't even have the money in the bank. This is where they get you. All right. So now we're going to see this. So now we want to know month deposit $50. So value of that after 12 months. Are we doing it for the year? After 11 months. What is this? They did this wrong. This is supposed to be a 1. Yeah, because it's after 12 months. What are they doing here? Value after that. Are they going backwards? They did this back. Okay, theirs is backwards, guys. I don't know what they're doing. This should be our last month. This is Edmentum being Edmentum. I'm so sorry. That's supposed to be our last month. This should be our 10th month. So if you guys do it the way Edmentum wants it, it technically is mathematically wrong. That's so annoying. I'm so sorry, guys. I'm looking at this and I'm like, that's month 1, not month 12. So, month of the. Let me read it. Maybe I'm reading something wrong. Complete the table to represent each individual month's uh, deposit of $50 worth at the end of 12 months. Answer the questions in this form. Yeah, this is backwards, guys. I'm sorry. The first month, they don't get any interest. The second month, they get 1 month of interest. 1 month of interest. The months after that, they're going to get 2 months of interest. Months after that, they get 3 months of interest. Months after that. So you can see where they messed up. I don't know why they automatically defaulted that, and I don't know why their sample answer is wrong, just so you know. So that's a good point to make. Remember, the teachers are checking for wrong answers, and sample answers aren't always the right answer. So I don't know. This one I felt was misleading. So it's a good thing you guys are taking this class to see that this one's wrong. You might want to make a note of that. Part C starts off wrong. And I'm sorry if my voice got a little angry there, but I really hate it when Edmentum puts the wrong answer. All right, so look at the expressions on the chart. Write them backwards as the sum. We're not supposed to write them backwards. They were written incorrectly. Use the sum to figure this out. So they want us to like add this all up. How much money did she earn from interest? So how much money did she earn from interest? Honestly, guys, like they want you to add all of this up without the 50 and stuff. Way too much work. Just do yourselves a favor. Just subtract it. Just go, all right, 50 minus, or sorry, 51.67 minus 50. Guess what? That's 1.67. Admentum is making you do more work than what's necessary here. Like you can look at their sample answer. They're like, oh, we're going to use the summation formula. Wait, after a year, we have about 600 savings after 12 months. So is she depositing this much money? Oh my gosh, she's depositing that much money every year. Either way, that's still wrong. Okay, that's me reading it wrong. I'm sorry, guys. I just got frustrated with them and I started assuming that they're going crazy. So they want you to figure out how much money she makes if she keeps depositing $50 every year. So complete the table is worth $50. Sum $50. Look at the expression, make it backwards, use the formula. How much money did she earn from interest? So this, what they're saying is, hey, we're gonna deposit another 50 on top of that 3%. So they did a terrible job at saying that. What's happening here is she is adding $50 every year plus the interest. So this one, I remember the math teacher, us math teachers got together. This one is really wrong. What they're saying is this is she's depositing $50 on top of getting interest from the month before. So there's no reason to ever do this in the real world. You guys can see the answer here. Take a screenshot if you need to. I'm just really upset about this one. I remember being in a meeting about this problem, and you would never do your math problem this way. So take a screenshot, go ahead, because you're not going to learn anything from this because it's not a real world problem. Your interest isn't that, and you don't add your money plus your interest. So let me make it a little more specific for you guys. Whoever wrote this problem doesn't know math. They're saying, like, hey, if I had $50 and the next month I get $50 plus interest, you don't get another $50. Okay. So that's where they're messing up here. This one is literally not doing math correctly. So you might see the anger in my voice. This isn't real. This isn't how money works. You don't add up your money. You don't go, oh, month one, I had this much money. You don't have month two because it doesn't work that way. Let's say, for example, Sammy, I'm going to borrow your name for a bit. Let's say Sammy had like $100 in his bank. And then the next month, he had $50 in his bank. After 2 months, it's not like he's like, oh, that means I have $150 right now. That's not how money works. So, this is a very bad word problem. I'm sorry about that. I'm just going to go through the answers because they don't know what they're talking about, and I can't teach it because they don't know what they're talking about. So, this next one, they're saying we got this much money. So, she has $3,000 in 2 years. What fixed amount should she be putting into her savings for 2 years? This makes a little more sense. This is asking, this one they know what they're talking about. They're saying, like, hey, she's gonna start off with $300, but how much money should she put into it every week? So what they're saying is we have no idea what she should put in there every single month. We know that she wants to get $3,000. So we need to figure out how much money she needs to put every month. So this one makes more sense. They're saying, like, hey, we need to figure out how much money they're putting in every month. So what they do is they solve for everything. They plug it all in and solve for everything. So if it's 3%, 3.6% a year, they're only making 0.003 in interest. Or you can say 0.3% interest. I like the decimal version better because you can't plug in percentages into a calculator. Calculators are stupid. Um, Percentages are just something that humans use to make it seem a little easier, but honestly, decimals are a way better way of saying things. So they plug it in, they solve for it, and they figure out, oh, she needs to put this much money every month. So to kind of sum up, this is what happens if you don't do anything. Where is the next one? This one over here for Elster is how much she does if she puts $50 every month. So she has to keep adding $50 every month. And this is figuring out like, hey, this is how much I'm saving up for. This is my interest. How much money should I put in every month? She should put in this much if she needs $3,000. So now we want to figure out a savings plan if she keeps getting the interest over and over and over and over and over again. So in order to do that, we're going to get this formula right here. So we're just replacing it with I. So this is our formula for interest. I don't know why they're doing this. It's not as useful as people think, because you could just plug it in with the numbers you want. This formula in itself is really good. This one, they're just plugging it in with I, substituting it. So this, again, this is your expression for this. Self-evaluation for this, I would put me at a 2. Admentum did not write the equations in a way I could understand. Oh, not equations, problems. Their equations were fine. I like how they give out the equations, but the problems are wrong. They never mentioned that she's putting $50 aside every month. How much would each monthly deposit? Oh, they did put it here. Oh my gosh, I'm like yelling at them, but they put it very subtly. Each monthly deposit. So she's putting in $50 every month. Okay. I'm a little less angry now. They just didn't do a good job with that. And my rant lasted too long, guys. So I'm going to have to release a third video. I promise to be more calm in that one. But they did a terrible job of explaining that problem. I'm sorry. I'll stop the recording right now. I'll release a third video on Friday. I'll record it after study hall.